Hi, everybody. Thanks for joining. Today, we have Keith McClellan with us. He is a director of partner solutions. He's director of partner solutions engineering at Cockroach Labs. Um, and Keith is going to go over the topic surviving CubeDoom. Even demons can kill an intrusion of CockroachDB. Very exciting title. You can reach out to Keith at Keith MCC on Twitter. Before we get started, quick recap that we have a channel on slack.kubernetes.io. That's hashtag meetupdc. If you want to get in touch or get updates on the talks and participate in the conversation. We also have a community page that is community.cncf.io/Washington-DC. That is the platform where we organize these events. So if you are coming up from meetup.com, please move over to CNCF, register there, and you will avoid the double registration problem. Also, if you are registered with community.cncf.io, when we post the video and the slides there, you can also get updates and look at the content later as well. And if you want to join our YouTube channel, look for DC Kubernetes Meetup channel on YouTube, where we upload our recorded sessions. The session is being recorded, and we will share the recording on the YouTube channel. With that, I would like to welcome our presenter Keith today and ask him to take it away.
Thanks so much. Thanks for having us. I'm going to share my screen. Hopefully this works the way we planned on it. Can you all see my screen?
Yep.
Great. So as Fahim said, my name is Keith McClellan. I'm the Director of Partner Solutions Engineering here at Cockroach Labs. Been with the company a long time. So beyond Twitter, you can also reach out to me at keith@cockroachlabs.com if you have any questions. I'm also joined by one of my coworkers, Elise, who, if you're also looking to follow up and you can't reach me, she'd be a great resource for you. And she's going to drop her contact information in the chat. So today's topic is surviving KubeDoom. And it's what we're going to be doing is we're going to be building a stateful app across 3 Kubernetes clusters using CockroachDB. And then injecting a little bit of chaos with the 1990s action game Doom. So I think that'll be kind of fun. I can't really see the chat while I'm presenting. So if you have any questions or I'm going too fast or whatever, feel free to unmute yourself and just interrupt me. It's totally fine. We have few enough people on the call here that we can handle live Q&A rather than trying to hit the chat. Before I get started, hopefully I sound okay. Everything seems to be working all right on my screen. Good. Excellent. So first off, what is CockroachDB? CockroachDB is a distributed SQL database that was built from the ground up for platforms like Kubernetes. And it was designed to solve the kind of vertical scaling problem that we see in traditional relational databases. So if you've ever run like Oracle, you know that you basically have to buy ever larger machines to be able to handle more work. And that kind of an infrastructure doesn't translate well to this cloud native ecosystem that we find ourselves in. And it certainly doesn't translate well to running things on Kubernetes. So we were founded by 3 former Google employees, and they built it to run on Borg largely, which is why it works so nicely in Kubernetes. So CockroachDB uses something called Raft, which is the same consensus protocol that Kubernetes uses itself to do consensus-based synchronous replication across pods. That means that when you write data to the database, it is always persisted into multiple locations, and we do kind of all the management for you there so that we can do kind of the system of record operational data store workloads that would be really, really hard to otherwise run in Kubernetes, right? So, and we scale out. Our performance scales linearly as we add nodes to the cluster. So what we do is when we need to be able to handle more transactions per second, Well, rather than having to go get ever bigger servers, we just add servers to an existing cluster. So that might be spinning up new stateful sets in Kubernetes. It might be adding new Kubernetes hosts to an existing cluster and then starting additional stateful set replicas. But it's very easy to scale, and you have a large certainty of how many instances and what size you need to be able to hit certain kind of workload requirements. This is really kind of great because if you were to run like a traditional clustered database, there's a lot of management that you'd have to do to kind of solve for those types of problems. And CockroachDB kind of just does it out of the box for you. Because we were designed to scale out, we were able to add the concept of placement to the data structure when we're defining tables and records and whatnot inside of CockroachDB. And so instead of just being able to scale out across, say, a single data center or a single Kubernetes cluster, we're able to extend that those same principles to a multi-cluster kind of a landscape. So what we see here is a single logical database. It's one CockroachDB cluster spanning in this case, three data centers, three different Kubernetes clusters across the continental United States. So what we're able to do here is we can do the same type of work we could do here with in a single data center, but across multiple data centers. And what we can do in addition to that is we can give users that are interacting with the local replicas kind of much more consistent performance than if they were, say, connecting to a database that happened to be on the other side of the country. Today, we're actually kind of taking this even a step further. We have one of our Kubernetes clusters in AWS, one of our Kubernetes clusters in Google, and one of our Kubernetes clusters in Azure. So this is a true multi-cloud, multi-cluster, multi-Kubernetes distribution deployment of a single CockroachDB cluster. This allows you to make an entire cloud provider your fault domain for failure scenarios, which is really helpful if you're worried about, say, an AWS outage taking your application down. So one of the things that this allows us to do is have kind of chaos ensue in just one of the regions, and we're gonna simulate that here today with this KubeDoom fork of Doom, which is going to be kind of fun. And we can do this with a zero recovery point objective. That means no data lost because we're doing synchronous replication. An RTO or recovery time objective of less than 15 seconds. That means that no matter what the failure, as long as it's a failure that the cluster is designed to survive. So by default, we're designed to survive any arbitrary fault domain failure. So any node failing or any region failing. We can guarantee an RTO of basically 2 election cycles with Raft, which I think we do a 9-second Raft election cycle. So I guess it's 18 seconds. And because of the way we do things, we are able to do no downtime rolling upgrades, and we do online schema changes as well. So there's no concept of having to take tables offline or any of the things that could disrupt the ability to do a fully auditable transactional workload on CockroachDB. A lot of our early customers and quite frankly, a lot of our current customers are using CockroachDB to process things where correctness is incredibly important. So things like financial transactions and inventory management, the types of use cases that traditionally you'd have, say, like a legacy RDBMS doing for you. That right now, if you wanted to be multi-cloud, there's just not a whole lot of options. Because of this, we can have users connecting to any node in the cluster and getting local performance and the ability to comply with data sovereignty regulations, a bunch of other stuff, which I'm not going to bore folks with because I think everybody wants to get to the fun bit. And because that we are already kind of cloud native and Kubernetes native, you can have all of your nodes running in Kubernetes. You can have some of your nodes running in Kubernetes. We're very flexible as far as that goes. I'm like blasting through this, by the way. So, because I know we're running a little short on time, and I want to make sure everybody has the chance to ask questions. Anything that anyone has seen so far that didn't make sense? Any questions?
I do have a question.
Go for it.
So, so when it's doing cross regions, right, or cross cloud, doesn't that entail like time issues, like synchronization? So normally, it's not a good practice for Kubernetes clusters to do cross region.
Right. So, so in Kubernetes, etcd is running all of its data in a single raft group. That means all of your consent, all of the data in any particular etcd instance has one replica that's the leader, and then the remaining instances of etcd are just followers. So, so you can get pretty fast reads from that one instance that has primacy, and the remaining nodes, they don't really do very much until they kind of unless they become elected as the leader, right? And so the challenge that you have in kind of a multi-region deployment of Kubernetes is the authority to act over the data is only on one of those etcd nodes that's in one of those regions. So what CockroachDB does to mitigate this is that rather than having a single raft group, we have this concept of ranges, which is used to be 64 meg segment of the key space. I think now it's configurable up to 512 megs of the key space. And so a subsection of each object has its own raft group. And so we'll have hundreds or potentially thousands of raft groups in a single CockroachDB cluster. The intent being that each of those raft groups has a single leader. We call it it's the raft leader, and then in the database we call it the leaseholder. And then we distribute the authority to act across all of the nodes in the cluster. So each individual node has the authority to act over some parts of the data as a follower for some additional parts of the data, but may not actually have the entire and the entire table or the entire database local to it, right? And then from a database perspective, we allow for either automated or manual optimizations to place the primary copy of any particular record or object as close to the users that are most likely to act on it as possible. So if you think of like a loyalty card type of use case, let's say I want to use points to go buy a coffee at my local coffee shop, right? 95% of those interactions are probably going to be within 20 miles of my house, right? And the loyalty card app knows what my where I'm logging in from, right? And so it sets my user ID to be a part of the ranges that have the primary replica located in whatever data center is closest to me. I live in Arlington, Virginia, probably like a lot of the folks on the call here in the Metro DC area. So of course it's going to be the US East region where my records are going to end up having the primary replica. Now, my data still exists in US Central and US West unless somebody explicitly went in and turned that off, which you can. But the primary replica is local. So I get really fast reads. I get local read performance, and writes are the local write performance plus whatever 1x my round trip time is between my local region and my next nearest region. So in this case, we're doing US Central. It's probably 20 milliseconds overhead on my writes. What's really kind of cool about CockroachDB is the more distributed we are, the faster we get, because my next nearest site generally ends up being closer to me when I'm more distributed. One of the reasons why this particular demo is really interesting, I'm only showing 3 regions here, but I could have done 12, right? I could have done 4 regions in Amazon. I could have done 4 regions in Azure. I could have done 4 regions in Google. And I could have all of my data really close to one another, but still be able to treat the cloud provider as my fault domain. There's just a lot of kind of nuance there that goes into making the types of placement decisions that are necessary. What's really cool is that CockroachDB does a lot of this stuff out of the box for you. We will move data to be to have its primary replica be wherever it's being accessed from the most, but dynamically. So you only have to think about this if there's specific either business rules or compliance rules that have you have to declare a particular topology, a layout of data across a multi-region cluster like this. Did I answer your question?
Does this?
Yes, it does. Thanks so much.
Yeah.
Go ahead, Oleg.
Keith, yeah, just to add to that question. So does this localization happen on per record basis or on per block, or what's called?
It can happen all the way down to, it can happen based on any characteristic that is in the primary key of the record. So we can go all the way down to the individual record. The one caveat there is that whatever piece of information has to live inside of the key, because the key is what we use to determine where something lives in the database, right? So, so this does impact database design a little bit. If you're running like an old school third normal form database in some like Oracle or DB2 environment, you're probably going to have to denormalize your location information so that we have something local to be able to make in the record to be able to make placement decision about. We can also do it synthetically. And so a lot of the kind of easy button stuff, we will do a synthetic kind of UUID based thing. And then that allows us to move individual records across ranges if necessary. There's a lot to unpack there. It sounds really hard. It's actually like stupidly easy to do. We've made it really, really, really easy, and it sounds more complicated than it actually is. So if you'd like a follow-up, I'd be happy to kind of dig into exactly how you would implement something like that.
Mm-hmm.
For what it's worth, I didn't do any of that work for today. So we are just using the database's like built-in self-healing and self-optimization functions for today's demonstration.
Yeah, very cool. Thank you.
Any other questions before I move forward? All right, well, feel free to jump in and stop me if I'm going too fast. So, out of the box, we look and feel like Postgres. We made this decision intentionally. We wanted to make sure that folks didn't have to go and download a new driver and work through all of that. We are 100% ACID compliance. We guarantee transactions up to the serializable level of isolation. This is the highest level in the ACID standard. If you're a database person, you know what that means. If you aren't, it's a really, really, really mathematically sophisticated way of saying that we will always give you consistent, correct information out of the database. We naturally work with storage classes and stateful sets. You can launch CockroachDB using static configs, a Helm chart, or an operator. Today, I'm actually using static stateful set configs, largely because it makes the multi-region networking stuff easier to do because there's a lot of other stuff that goes into that. And we're pretty well known in the community. Lots of folks run CockroachDB on Kubernetes. There are over 2,000 long-running clusters in the community that have been running CockroachDB on Kubernetes for a really long time. And our internal SaaS platform, both our serverless database and our like dedicated hosted database, both also run 100% on Kubernetes. So when we say that this thing is rock solid in Kubernetes, we kind of eat our own dog food on that one. What we're going to be looking at today is self-hosted, mainly because that allows me to like go monkey around with the plumbing, which was required to get the KubeDoom stuff working the way we wanted it to. So I think it's probably going to be clear to everybody where we're going to slides that I made as opposed to slides that somebody else made. What we have is a single CockroachDB cluster running in EKS, GKE, and AKS. I think this one we're actually running 9 pods, 3 in each region. Today, I did a flat network where we're using VPN gateways between each of the different Kubernetes providers. I have a version of this demo that I've used Scupper with. I've also done this with Submariner. CockroachDB largely doesn't care as long as we're not incurring an inordinate amount of kind of latency overhead. And I have workload generators running in 2 of my 3 regions, in the EKS region in the west and in my GK region in central. And then I've got KubeDoom running in the east. This is where I'm going to be killing pods. Okay. So hopefully everybody can kind of see. Oh, it's not. I got to change tabs. Okay. So we're now looking at the CockroachDB console. We're moving to the demo portion of our festivities today. You can see we're running it looks like a 9-node cluster. I've got 3 in US West 1. I've got 3 in US East US, that's the Azure region, and I've got 3 in US Central 1A. I am running, I've got some query load running, not a substantial number of queries, 70-ish queries a second, just enough for everybody to see that like this is a real live active database. I could have pushed this up to probably 1,000 queries per second, but I just didn't do any of the work that be required to do any of that optimization. And what we're going to do is we're going to start to see nodes in this Azure region on the East Coast start to go down. So we got 3 nodes here. All of these nodes have been up for more than 24 hours, and that's kind of where we're going to be at. So I'm going to go ahead and stop sharing again. And now I'm going to share my entire screen. So hopefully nothing embarrassing happens while we're doing this. So everybody should be able to see the cluster overview screen on the left-hand side. I'm going to make it smaller. You also get to see my cheat sheet notes to make sure that I actually have, I have to use a lot of cheat codes, so please don't be upset with me that I have to use a bunch of cheat codes to be any good at Doom. I haven't gotten any better at it in 30 years. And you can see I've got 2 workload generators running over here on the left-hand side, and then my port forward to this VNC connection. KubeDoom is running as a deployment in my West Coast or my East Coast region. Let me zoom out here a little bit. All right. So KubeDoom is running over here in this Azure region. So as you can see, I'm kind of rocking around here. I am at the very beginning of Doom, and I've used cheat codes. So I have the BFG to get started. So I go over in here, and you can see I've got 3 daemons in here. And they're my 3 CockroachDB pods. So I'm going to go ahead and kill them. It's like I got 2 of them, and one of them's over there. I'm going to go get him. Told you I was not good at this, right? And you see on the left-hand side that we have 3 nodes that went dead and then suspect. The reason they went suspect is because Kubernetes restarted them. Because Kubernetes is really fast about restarting pods. when they doesn't have to move it. So I'm going to go ahead and kill some of them again before they get fully resynced. This is like total chaos that we've got going on here, right? I can't even kill them fast enough because they keep getting relaunched as quickly as I can kill them. But you can see we have some under-replicated ranges. What that means is that because we're running at 3x replication here, it means that effectively some ranges are running in single point of failure mode. And we see that the instances are healing. You can also see that my load generators in my 2 regions where I wasn't killing instances are running as normal, right? So I'm still running some transactions per second. Looks like I took a little bit of a hit from a performance perspective when the system was kind of like losing nodes left, right, and center, but we were able to get that fixed here pretty quickly after just kind of letting it hang out for a minute or two. So let me go ahead and go back to sharing my presentation. So back to what we were talking about, right? We had instances over here on the East Coast running as a part of a single CockroachDB cluster, and we just started killing nodes randomly, and the database kind of just took it in stride. We can do a lot of the things that you need to do in CockroachDB to just kind of make this easy. So I'm happy to talk a little bit about that more. Looks like we have about 15 minutes left, so happy to answer some more questions. I did mention we do have a Kubernetes operator for making it easy to deploy CockroachDB. For multi-cloud kinds of use cases, probably wouldn't recommend the operator because there's no kind of multi cluster operator construct. But there's plenty of options for solving that problem as well. And if you're interested in learning more, we offer free online computer-based training called Cockroach University. We've got a number of different classes, getting started with distributed databases, building your first app with, I think, 4 or 5 languages now, and a bunch of other kinds of modules and whatnot as well. So that was the presentation. I would be happy to talk through any other questions anybody else on the call might have.
All right, thank you so much, Keith. That was pretty cool. So yeah, if anybody has any questions, they want to unmute themselves and ask questions, or they want to just write it up in chat, that is fine. I can read it. I see a question from Deshaun Carter. It says Spring Data.
So are we talking about like the Spring application framework?
Not sure. Deshaun, you want to expand on that?
Yes. My boss is actually a big Spring Java developer, and we have lots of examples of building applications on Spring. We have native CockroachDB support in something like 30 ORMs, including the major ones that get used in Spring. So I think we've got you covered there. If you ran into any problems, I'm not the person to ask, but I know exactly who to connect you to. So feel free if you get stuck there, you want to try CockroachDB for a project, happy to connect you with the folks that have all of the examples for that.
All right.
Come on, somebody else has got. I blasted through all those slides, so somebody's got to have a question. Something I skipped.
So, do you guys have any like a community edition, or if somebody wants to like give it a go on their own?
Yeah. So CockroachDB is open source. So the self-hosted, there's 2 editions of self-hosted. So there's core, and then there's kind of enterprise. Mm-hmm. Enterprise is a licensed offering. It's paid for. Core is free. It was under the Apache license for a really long time. Now it's under the BSL, but the only BSL constraint it's under is you can't build a database as a service offering and use CockroachDB without our written consent. So it's still Apache. It's still effectively an Apache license for anything that anyone's likely to use CockroachDB for. The features that are gated behind the enterprise license are things like incremental backups, some of the Kerberized security, and some of the multi-region fine-grained placement constraints. So all the stuff I showed today, with the exception of the map, is all core. The map, for whatever reason, I think we have to pay Google to use their mapping engine for the UI. So the node map is actually locked behind the license key, but everything that we did today from a functional perspective is all core functionality. None of the stuff that I showed you today requires the enterprise license. Now, if you were in like a financial use case, or you cared about having Kerberized security or one of the other like 5 or 6 different enterprise features that's locked behind the license, then there's a cost to that. But so a couple of questions. How is CockroachDB different from Atlas from MongoDB? So MongoDB is not a relational database, so it's a document store, right? And the way they handle transactions is very different. So one of the dirty little secrets of Mongo is the transaction guarantees in MongoDB are only single document guarantees. And as soon as you're cross-document, so if you have a cross-document transaction in MongoDB, you have lower consistency guarantees because there's more likelihood that you'll have like a conflict between different transactions because just because of the way they replicate data and all that kind of stuff. You wouldn't really use us for the same use cases. Like we're focused on auditable financial transactions. Not necessarily. So that's not necessarily like their bread and butter, right? So it's not really a direct. There's not really a direct comparison. We don't run into them that often, quite frankly. We're much more apt to run into like Amazon Aurora or Oracle or DB2 type of an installation than a MongoDB. Did I answer your question?
Yeah, sort of. So the reason I was asking was Mongo also, and when I talk about Mongo, I'm not talking about MongoDB, but I'm talking about Atlas, which is built for the cloud offering. They guarantee, they're actually saying that they're going to guarantee the asset properties of a database, and all of that is coming from people who have used Mongo, and the transition to Atlas is very seamless. I personally, the schema in MongoDB is very complex, but I don't know, the performance guarantees are what in comparison to Cockroach, but yeah, I would love to sort of dig deeper there.
Yeah. So when someone says that they are providing ACID guarantees, there's a lot of white space there. So particularly around consistency. So there's like 6 or so different levels of consistency that you run into in databases. The lowest one is read committed, write committed, and then repeatable read, and then there's a couple that you very rarely run into, and then you've got snapshot, and then you've got serializable. Okay, serializable which is what we do, is the highest level of ACID guarantee. Most databases on the planet don't hit it. The only one that hits it is Google Spanner. They're fully serialized all the time. They're actually technically linearized, which is not covered in the ACID paper. They do that. They use they literally use atomic clocks to synchronize their time windows between all their instances across regions. So we're using something called a hybrid logical clock. If somebody wants to geek out about like time theory, I'd be happy to talk about that at another time. So we're fully serialized, and what that means is that regardless of the latency between nodes, we are guaranteeing that each key only gets mutated as one at a time. So that's what's required to be able to do fully auditable financial transactions. So which is part of the reason why we're so popular in kind of like the real money gaming space, i.e. gambling space. We're also really popular with online banks because we make it really, really easy to not have to worry about whether or not your financial transaction actually happened. Even with something like Oracle, which runs by default in snapshot mode, is still vulnerable to certain classes of acid attacks called acid rain attacks, where multiple endpoints try to deduct money from the same account at the same time, and both are able to get that money out. You can imagine for gambling use cases and banking use cases, that's never acceptable, which is why a lot of these banks are still running DB2 on the mainframe and have been for 35 years. So when Mongo says that they're providing ACID constraints, they're largely saying that they're providing like repeatable read ACID constraints. That's not a bad thing, by the way. Actually, it makes them appropriate for a ton of use cases. So please don't take this as like a dissing thing, but I don't know of anybody trying to run auditable financial transactions on MongoDB. Whether it's somebody managing their own MongoDB cluster or Atlas. They're just designed for different things. Like we went full, we're like, as far as like a CAP theorem database, we're full CP, right? We are as consistent as you can be from a CAP theorem perspective. And then we hacked in a consensus protocol to give us variable availability depending on how you want to set up your environment. And the trade-off there is availability versus kind of best case performance, right? Whereas Mongo generally is more of a like an AP kind of a structure that's trying to give you certain consistency guarantees. It's really just not. It's not really an apples to apples comparison. Was that clear as to what I was talking about versus what maybe they're talking about?
Okay, I think I muted Surab because I was getting some noise. But Surab, feel free to unmute yourself if you have.
Yeah, this was helpful. Thank you, Keith.
No problem. Please don't take that as me bashing MongoDB. There are plenty of different projects where I would use MongoDB over CockroachDB, right? It's just, we weren't designed to do the same thing, and we're all talking the same language, but it's not necessarily that we're not necessarily saying the same thing.
Okay.
Absolutely. Driven, and I totally understand that.
Yeah.
Thank you.
There's another question from Dishan about ARM64 support.
So CockroachDB is run on ARM for a really long time. You can download the source code and compile it for ARM, and it's great. Even last year's cloud report, they compiled a custom ARM64 binary and ran benchmarks using it. That's pretty cool. We still don't currently offer official ARM64 binaries. I suspect that's going to change this year because we're starting to get a bunch of M1 Macs. And so the engineers are going to get annoyed that they're having to do their own custom database build. So we'll probably end up with ARM64 binaries before the end of the calendar year. Largely when the 10 most prolific engineers all get upgraded to M1 Max, I think we're going to end up with ARM64 official binaries, but it hasn't happened quite yet. So right now, if you wanted to do ARM64, it works fine, but you would have to run your own build. But we have folks that have run it on like Raspberry Pis. We ran it on Graviton processors in AWS last year as a part of the cloud report. But it is not something that is like super robustly tested. Like we don't spend a bunch of Like all of our nightly stability and performance testing is all still done on x86.
All right. I think there are no more questions. This is a wrap. Thank you so much, Keith, for coming on. So I'm sorry we had some technical difficulties. We probably lost a few folks there in the beginning, but we recovered. And thank you, Elise, for offering this. Hopefully, we'll have you guys soon in person once we start doing in-person meetups.
Excellent. Thanks so much. It was a pleasure.
All right. Thank you all for joining.
Bye.
Thank you. Bye.
Nice meeting everyone.
Bye.